Alright, welcome back. In the previous page, we have mentioned how to construct an inverted index, which can make use of the storage space in a much effective and efficient way. However, it will also create some problems for us to answer queries, right? Because it is no longer based on the Boolean expressions. In this page, we want to show you with the example to answer the Boolean queries based on a new inverted index instead. Let's assume we have to query input Brutus and California. In other words, we need to find the documents contains both Brutus and California, these two terms. Then how can we do this? So to answer the queries like this, the process will have several steps. First of all, given the query input, we can find all the terms mentioned in the queries, right? We have Brutus and California. So for these two terms, based on the previous inverted index, we can find all the matching documents for them. We locate the Brutus in the dictionary and also retrieve its postings ID list, right, from the posting file. In other words, based on the inverted index we mentioned before, we can find all the document IDs which can contain the Brutus in it, right? It will also be very similar for the California. We can also locate the California in the dictionary and retrieve all its posting list from the posting files. So we can show the example at the bottom. For the Brutus and the California, we can find their posting list like this, right? It can contain all the document IDs which can contain these words in them. So here the problem we are starting is to do the AND between Brutus and California, right? In other words, we need to find the documents contain both Brutus and California. Then the next step we can do is to do the intersection between these two posting lists. So given these two lists, we can do the intersection between them to find common documents between these two lists. And then we can return this intersection to the users instead. In the bottom, we show the result for the intersection step. Given the two lists of the Brutus and California, we do the intersection, which will return the list 2 and 31st. In other words, for the document 2 and document 31st, they will contain both Brutus and California at the same time. So this is the process for us to dealing with the queries, based on the new inverted index we created before. Okay, so in the previous example, we mentioned a query with only two term inputs. And when it comes to a more complex query with multiple terms, like n terms, here the n is larger than 2. Then how can we deal with it? So the algorithm for answer a query like this will be like, for each of the terms, we can get its posting list and then do the intersection that among them together. However, here we will have one challenge because we have so many different posting lists for each of the terms. Then what is the best order for processing the query? For example, we have a query Brutus and California and Caesar. How can we answer this query? We have different orders to do the intersection among them, right? We can do the intersection between Brutus, California first, and then do the intersection with Caesar. Or we can do the intersection between California first with Caesar, and then do the intersection between them with Brutus, right? So the order for do the intersection among these terms, among the document ID list will be very interesting. Here we show a very simple and effective optimization technique which can deal with this problem. Here we can process the intersection among different terms in the order of increasing frequency. In other words, we can start with the shortest posting list and then keep doing cutting further. In this example, among these three terms, based on this posting list, we have Brutus, California, and Caesars. Among them, Caesars, the posting list is very short. Therefore, we can start with Caesar first and then do the intersection with California because this one is shorter than Brutus list, right? And then, based on results, we can further do the intersection with the Brutus list instead. So this allows us to answer this query in a more efficient way, and you can compare the time cost for answering the query according to the order we show here, or according to a random order. You can also calculate the time cost by yourself on your paper to see the difference, right? And also to show why a simple method is very effective and efficient. Okay, so this is to answer the queries based on this new inverted index we created before, based on both the dictionary as well as the posting list for the documents. Okay, next we will move to a new part for answer query based on the multiple dimension indexes instead.